Welcome back. Today we're going to be talking about irrational numbers. Our content objective is students will be able to determine whether a number is rational or irrational, and we're also going to be estimating irrational numbers. Our language objective is students will be able to describe the difference between a rational and an irrational number. Why am I learning this? Well, it's important for solving real-life problems like using estimates of irrational numbers to approximate the diagonal length of a rectangle. So first we're going to go over some background knowledge. In the previous lesson, we did talk about what a rational number is. By definition, we said that it's a number that can be written as a ratio of two integers, aka a fraction. So here are some examples. All of these examples are rational because I can express them as fractions. And then the two types we talked about were terminating decimals as well as repeating decimals. We're able to convert both of these types into fractions, therefore they are irrational. But then we also talked a little bit about irrational. Irrational numbers are numbers that cannot be written as a ratio of two integers. So in other words, it cannot be written as a fraction. So square root of 5 was an example, pi was an example, and this number here was an example as well. Because all of these are not able to be written as fractions. So today our focus is going to be more on irrational numbers in comparison to the previous lesson that was more about rational numbers. Now, we did talk about how rational numbers are basically the two types we saw were terminating decimals and repeating decimals. In the same way, irrationals are numbers that cannot be written as a fraction. You could also think of it as irrational numbers that do not terminate and do not repeat. Now, before we move on, I do want to mention something. Here, a number that I can include into the irrational list would be the square root of 49 because it's 7. And 7 can definitely be written as a fraction. Now, how do I tell the difference between the square root of 49 that's rational and a square root of 5 that's irrational? How am I supposed to decide which one does it go into? Is it rational or is it irrational? Let's take a closer look. A square root is basically an operation that yields a number which, when multiplied by itself, produces that given number. So for example, the square root of 144 is 12. And why do I know this? Because 12 times 12 is 144. The square root of 100 is 10. And how do I know this? Because 10 times 10 is 100. What about the square root of 10? Well, I can't think off the top of my head a number that I can multiply by itself that will give me 10. And why is that? Because this one isn't a nice number. It's not a perfect square. It's approximately 3.16227766017. Here, this number does not terminate and does not repeat. And for that reason, we know that it's irrational. Same thing with the square root of 50. There's not a number that I can multiply by itself that will give me 50. In fact, it's approximately 7.071067811187. It's not repeating and it's not terminating. So how can I classify them? Well, if the square root is a perfect square, which means I can figure out the number that when I square it gives me back to this number, then it is a rational number. Because again, I can write 12 as a fraction. The same way I can write 10 as a fraction, 10 over 1. It is rational. Now, with this example here, it does not terminate, it does not repeat, therefore, there's no way for me to write it as a fraction, so it's irrational. Same thing here, it does not terminate, it does not repeat. So, for those reasons, I can't write it as a fraction, and because of that, it is considered to be irrational. So let's take a look at some examples here. The instructions say to identify each number as rational or irrational, and to explain. So here, for number 1, I'm going to say the square root of 10 is irrational. Again, because nothing times itself is going to give me 10. That's a nice whole number. What about the square root of 25? This one would be rational. Why? Because the square root of 25 is 5. What's 5 times 5? 25. So this one's rational. Number 3, the square root of 15 is going to be irrational because, yet again, there's not a number I can multiply by itself to give me 15. What about number 4? How do I read this? Well, kind of like the way we would read exponents, I would read this as the opposite of the square root of 49. Is there a number that I can multiply by itself to give me 49? Yes, it's 7. So what is the opposite of the square root of 49? I would say -7. So obviously, because I can write it as a whole number, I can also then write it as a fraction. So this one's rational. And what about number 5? Well, 50, that is going to be irrational. I kind of saw it in the previous slide. This number doesn't work out nicely at all. So therefore, it's irrational because it doesn't terminate, nor does it repeat. Okay, so at this point, what I would like you to do is go ahead and pause the video and try numbers 6 through 12 on your own. Okay, let's see how well you did. Number 6 is rational because you can express it as a fraction. This is 25 hundredths, which would reduce to 1/4. Number 7 is also rational because you can write it as a fraction. We learned this in the previous lesson. It's just 4/9. Number 8 is also rational because the square root of 121 is 11. Why do I know this? Because 11 squared is 121. All of these numbers can be expressed as fractions, and that's why all of them are rational. Number 9 is irrational. This number never terminates and never repeats. Number 10 is rational because it can be written as a fraction. We went over how to convert repeating decimals into fractions. So if you have no idea how I got this number, please refer to the previous lesson. Number 11 is irrational. It's not a perfect square. I can't think of a number that when I multiply it by itself is going to give me 22. And number 12 is irrational. It does not terminate and it does not repeat. So irrational numbers is, first of all, it's going to include pi, but it's basically decimals that go on forever without repeating. So again, it doesn't terminate, it doesn't repeat. But it also will include non-perfect square roots. So this is not a non-perfect square root. What else? And that was the only one in this particular one. But notice here, this is a perfect square root, and that's why it is rational. But these are the 3 general types. Okay, so let's take a closer look into what a square root was. I kind of briefly mentioned it in the beginning, but let's go more into detail. Again, it's basically an operation that yields a number which, when multiplied by itself, produces that given number. So in other words, if you square it, you should get the number within that square root. So again, square root of 49, it's going to be 7. And how do I know this? Because 7 times 7 is 49. Now, if a is greater than or equal to 0, then if I square it, it equals b. Therefore, a is the square root of b. So real quick, some perfect squares would be 0 squared, which is 0. So 0 is a perfect square. So if I take the square root of 0, the answer is 0. Okay, if I do 1 squared, that's 1. So the square root of 1 is 1. Let's generate another perfect square. What if I do 2 squared? That's 4. So 4 is a perfect square. If I take the square root of 4, I'm going to get 2. Same idea. If I want to generate another perfect square, if I do 3 squared, that's 9. So 9 is a perfect square. Take the square root of 9, it is 3. So notice it keeps going back to the number that was being squared. Let's do one more. If I do 4 squared, that's 16. So 16 is a perfect square. If I take the square root of 16, it's going to give me 4. So you can definitely generate perfect squares. You just take a number, square it, and there you go. You have a perfect square. So every positive number has 2 roots. So let's take a look at the square root of 64. There's going to be a positive square root and a negative square root. The positive square root would be the square root of positive 64, which is 8. And then a negative square root would be negative square root of 64, which I would say is negative 8. Now, the positive square root is also known as the principal square root. It's just something I want you to know. You won't be tested on this. So just remember there are 2 different types of roots. Now, real quick, so we have a positive square root, we have a negative square root, but what if the negative was on the inside of the square root like this? This is going to be no solution. Why? Because usually we'll say, oh, it's 8, but 8 times 8 is 64. And then someone might say, well, okay, well, maybe it's -8. Well, -8 times -8 is also 64. There's no way I can multiply the number by itself and give a negative number. So for now, we're going to say no solution. So you might be wondering, why are you saying for now? Because later in the future, when you go to high school, you're going to go a little more into detail with this concept and you're going to learn about imaginary numbers. But for now, we're only just going to call it no solution, which you would be typing onto your homework assignments, just so you know. Okay, so let's take a look at some examples. I'm going to go ahead and go over 4 of them, and I'm going to have you try 4 on your own. So real quick, the square root of 49 is going to be 7. Why? Because 7 times 7 is 49. Number 14, I would read this as the opposite of the square root of 25. Well, what number times itself gives me 25? It's going to be a 5. So the opposite of the square root of 25 is a -5. Number 15, the square root of 144. What number can I multiply by itself to give me 144? That's going to be 12. And number 16, what's the square root of 400? The answer is going to be 20, because 20 times 20 is 400. So at this point, I would like you to pause the video and try numbers 17 through 20 on your own. Okay, so let's see how well we did. Number 17, the opposite of the square root of 36 is a -6. Number 18, the square root of 36 is just 6. And number 19, the opposite of the square root of 64, it would be a -8. And what about number 20? What's the square root of a -100? The answer would be no solution. And again, for now, because negative numbers don't have real roots. In fact, they're called imaginary. But again, we're not going to cover that in the 8th grade. You will see that later in the future. Okay, so what about this one? I know it seems a little daunting because you see a fraction, but don't let this scare you. Here, all we're doing is we can break this up and say, okay, I'm going to take the square root of 16. I'm going to take the square root of 25. So here, what's the square root of 16? 4. What's the square root of 25? 5. And there you have it. And that's it. So at this point with this example, I would like you to go ahead and pause the video and try numbers 22 to 25. Okay, so let's see how well we did. For number 22, you're going to take the square root of the numerator and the denominator. So the square root of 4 is 2. Square root of 121 is 11. So I would get 2 over 11. Number 23, I'm going to take the opposite of the square root of 36 over 144. So I'm going to take the square root of 36, which is 6, the square root of 144, which is 12. So I'm going to get -6 over 12, but that can be reduced to a -1/2. Number 24, the square root of 9 over 49 is going to be 3/7. And number 25, the opposite of the square root of 100 over 169 is going to be -10/13. So please make sure this you recognize as the opposite. Now, if it was in the inside, then you can go ahead and refer to it as a negative. Okay. So now what we're going to do is we're going to estimate, okay, by determining what 2 consecutive integers a number lies between. So here, if I had the square root of 7, what I'm first going to do is take a look at my perfect square. So here I went ahead and generated a chart. 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. Right now, what I'm going to look for is where does the square root of 7 fall in? I would say that falls between the 4 and a 9, because 7 falls in between that range. So here, I'm going to go ahead and say it's going to be between the square root of 4 and the square root of 9. And this is how we would annotate it. It just basically means the square root of 4 is less than the square root of 7, but the square root of 7 is less than the square root of 9. So now what we're going to do is we are going to simplify what we do know. I know the square root of 4 is 2. And I know the square root of 9 is 3. So here, the square root of 7 is lying between 2 and 3. So if you think of it on a number line like such, the square root of 7 falls somewhere in between a 2 and a 3. So I'm just going to say it lies between 2 and 3. Let's try another one. What about the square root of 20? So again, looking at my chart, my chart of perfect squares, which I highly suggest you write this somewhere down on a piece of paper so you can refer to it. But it's not difficult to regenerate whenever you need it, so it's not something you always have to have with you. It can definitely be generated by hand. So here, what does 20 fall between? Well, I'm going to say it falls between 16 and 25. So I'm going to go ahead and say it's between the square root of 16 and the square root of 25. And again, I would annotate it like this. And on my open math, you will be expected to write these in, so just keep that in mind. Now what I'm going to do is simplify what I do know. The square root of 16 is 4, and the square root of 25 is 5. So right now I know the square root of 20 lies between 4 and 5. So the answer is going to be somewhere between these two numbers. So I'm going to say it lies between 4 and 5. Okay, so at this point, go ahead and pause the video and try numbers 28 to 31. Okay, so let's see how we did. Number 28, the square root of 56 lies between the square root of 49 and the square root of 64. And I know the square root of 49 is 7, the square root of 64 is 8, so I'm going to say it lies between 7 and 8. Number 29, the square root of 32 falls between the square root of 25 and the square root of 36. Square root of 25 is 5, the square root of 36 is 6, so I'm going to say it lies between 5 and 6. Number 30, 94, let's see, that's going to fall between the square root of 81 and the square root of 100. So I'm going to simplify to say that it's going to be between 9 and 10. Number 31, the square root of 3. The square root of 3 lies between the square root of 1 and the square root of 4, which simplifies to 1 and 2. So I'm going to say it lies between 1 and 2. Now, what if you were asked to estimate each number to the nearest integer? What do we do then? Because before they just asked for a range, got it. But now they're going to ask me what will the answer be closer to? Okay, so let's see. We're going to do the same thing. So for here, the square root of 8, I'm going to say it falls between a 4 and a 9. So I'm going to say the square root of 4 and the square root of 9. Well, the square root of 4 is 2 and the square root of 9 is 3. So it's going to fall between 2 and 3. But if you think about it, where does that fall closer to? Does square root of 8 fall closer to square root of 4, or does square root of 8 fall closer to 9? Hopefully you can see here that it definitely is closer to square root of 9. So I'm going to say it's approximately 3. Why? Because the square root of 9 is 3. So I'm going to say it's closer to square root of 9, therefore it's approximately 3. Okay, so let's take a look at another one. And real quick, I am using this particular symbol. It means approximately. We don't want to use the word equal because that's deceiving. It's not exactly 3. Okay, so taking a look at another example. How about the square root of 17? Again, I want to take a quick look on what it lies between. I'm going to say it lies between square root of 16 and square root of 25. So I'm going to write that. Square root of 16 is 4. Square root of 25 is 5. So it's going to fall between 4 and 5. But now I have to decide what's it going to be closer to, 4 or 5. So real quick, I'm just going to illustrate this on a number line. Square root of 16 is 4. Square root of 25 is 5. So putting that into place. You'll see here the square root of 17 is definitely closer to 4. And because it's closer to the square root of 16, I'm going to go ahead and say that it's approximately 4. So please make sure you're using that symbol. Okay. Number 34. I'm just going to go over 2 more examples with you, and then I'm going to have you try some on your own. So here, the square root of 35. So I'm going to say it falls between the square root of 25 and the square root of 36. Square root of 25 is 5. Square root of 36 is 6. So which one is it closer to? Well, let's take a look. Square root of 35 is right here. We have the square root of 25, which is here, and the square root of 36, which is here. It's definitely closer to 6. So I'm going to go ahead and say, because it's closer to square root of 36, I'm going to say it's approximately 6. Okay, well, last example for me. Here we have square root of 31. We have, I'm going to say it's between the square root of 25 and the square root of 36. So that's going to be between 5 and 6. Now taking a look at a number line. I'm going to go ahead and pinpoint square root of 31 is right here. I'm going to go ahead and identify square root of 25 is here. Square root of 36 is here. Now which one is it closer to? On a number line, it's kind of a little bit easier to see. You can definitely see it's closer to 6. But how would you do this without a number line? Well, you can find the difference between the two. So you're trying to find the distance between the points. Between 25 and 31, how far are they apart? Well, you can just find the difference by subtracting them, and you would see that they are 6 apart. Now here, what about 31 and 36? Again, if you want to figure out the distance, simply find the difference between the two. So here, the difference between 36 and 31 is 5. So even though it's just slightly closer, I'm going to go ahead and say that it's approximately 6, because it is technically a little bit closer to square root of 36 than it is to the square root of 25. So on that note, I would like you to go ahead and try the next 4 examples on your own. Okay, so let's see how well we did. Number 36 is going to be between 7 and 8. 53 is definitely closer to 7, so I'm going to go ahead and say that it is approximately 7. How did I know that? Again, if you want to find the difference between the two, I would say between 7, it's about 4 apart. And then between the 8, I would say it's about, let's see, 64 minus 53, 11 apart. Okay, so that's how you would check it. Number 37, between 64 and 81. So that's going to be between 8 and 9. You can definitely see here it's definitely closer to square root of 64. So I'm going to say it's approximately 9. Number 38, 76. That's going to be between 64 and 81. Which one is it closer to? I'm going to say it's closer to 81 because that's only 5 apart, because here it would be 12 apart. So I'm going to go ahead and say that between 8 and 9, it's definitely closer to 9. Number 39, how about the square root of 140? Well, it's between 121 and 144. Which one is it closer to? Absolutely 144. So I'm going to go and say it's closer to 12. So I'm going to say it's approximately 12. And again, the reason why we say approximately is because it's not exact. If I were to say 12, that would be misleading, because 12 times 12 does not equal 140. Okay, so that's actually going to conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.